So I'm a computer scientist. I'm actually a professor in computer science here across the street at Stanford. And what I do in my research, can I get my clicker? Great. So what I do in my research is to basically try to analyze social and information networks, combine that with large-scale data analytics to build computational models of human behavior. And in particular, kind of where the work that my research group is doing starts, it basically starts by this realization that everything we humans do today leaves some digital trace on the web, in a sense, right? So basically, we can use these digital traces of human activity and the web as a way to study humanity and understand how we humans behave and so on. And one important realization is that when we want to analyze this kind of data, we humans are not this kind of independent particles that are moving around in the space, but we are embedded in networks, right? We are basically in constant interactions with each other, and it is through these networks where we learn about new things, where we interact with each other, and so on. So basically, what my group does, we are using web data, study it in terms of this information and interaction networks, and try to understand how we as humans behave. And what I want to do in the rest of my presentation is show you 3 vignettes of how you can use kind of online web social data to understand human behaviors and what's going on. So the first thing that I want to discuss is today in the morning, we heard a lot about the importance of social communities, patient support communities, patients finding others with similar diseases and similar symptoms, exchanging information with each other, and kind of helping each other. So one important question in this kind of space is to understand, how do we humans, how do we people become members of communities? And here I mean community by very broadly. Basically, you change a community when you change your workspace. You change a community when you go to a new university and so on. And what would be really cool is, for example, if we could look at, I don't know, your first behavior in the first week at job, and we could say, how long will you stay at this job? Or how long will you stay at this community? Can we kind of predict these types of behavior? And the way, kind of the lens or the window into trying to understand these behaviors is actually through language. It turns out that language practices, but by this I mean norms and etiquette, certain conventions and so on, basically build both collective identity and allow us individuals to express ourselves. Right? So in a sense, linguistic change and the change in language inside communities captures the relationship between individual members and the community at large. So what we did is we went online and we collected complete linguistic records for 2 very different online communities. So the first online community is a community that discusses beer. Right? So these are people who are talking about beer. Here, the community is called beeradvocate.com. It's about 10 years of data, and it's a complete linguistic record of kind of every single discussion about beer on this site. And here I show you an example of how if you are a real community member, then this is how we talk about beer. Right? So you say that the beer has clear copper-colored brew, medium cream-colored head, and so on, right? So kind of heavy with jargon and kind of non-obvious vocabulary. Another community that we looked at is actually a community of breast cancer patients, right? So here, again, I'm showing you a little snippet from one of the posts on this discussion where a person talks about their disease and how they went to see the doctor and so on. And I underlined kind of certain words that are kind of domain specific, and you really need to kind of become a member of the community to understand what these words mean and to learn how to talk about your disease or your symptoms in this case. Right? So, and what I'll show you is basically that these 2 communities are no different, even though one is kind of about beer, and you would imagine kind of to be very different from another one, which is really about diseases and human problems. Right? So the first thing you can ask is, how does human behavior, individual users' behavior, change as a function of time in these communities? And for example, one thing we see is that as the time goes on, people talk less about themselves, and basically they talk more about the disease or the beer. Right? So what I'm showing you here is basically that as a function of time, the use of first-person pronouns, words like me, my, myself, health, and so on, decreases as a function of time. And the way you can understand this is to think of this as this is a sign of increased identification of a person with the community. So that's kind of how an individual user changes. You can also look how the community changes as a function of time. And here's, for example, how the beer community changes over time. So what happens to the beer community, if you are a beer expert, then you would know that today the way we describe beer is to use fruit words, right? So we say that the beer has a citrusy flavor and has grapefruity tones and so on, and this is not something we were doing 10 years ago. And you find similar patterns also in the breast cancer community, right? So also the way basically the global community aspect changes over time. So the next question I would like to ask is basically now if I have some global community language change and I have a personal individual language change, how do the two relate? Right, and the way I'll explain you this is because then we will later want to be able to, let's say, predict when a person is going to leave a community or how long they will stay in it. Right, so the idea is the following. I have the time, and my y-axis is just some kind of abstract space of how the overall language of the community changes as a function of time, right? Just kind of some trajectory in this abstract language space. And of course, I have also individual users who are basically, changing and evolving at their own pace and in their own trajectory. And what we can do and quantify is how does the distance or the similarity between the user's language and the language of the community change as a function of the person's lifetime. And if you quantify this distance, for example, what you find is that basically people's language early on is very far from the community and then kind of slowly converges or the distance decreases as a function of time, right? So what this tells us is basically something like this, right? So kind of you start away, you have your own language, and then you slowly kind of adopt the language practices of the community and you get closer. However, what is interesting is that kind of in the second part of a person's lifetime, the distance starts to increase again, which basically means that the language that the person is speaking seems to be getting more and more different from the language of the community. And there are two ways to think about this. One way to think about this is that kind of the person starts being off topic or starts to developing some innovative language that nobody else follows, and the gap increases. Another way to think about this is to think that basically the person stops adapting to the community, and basically the community itself, the world itself, will kind of move away from that person. And the way to distinguish between these two hypotheses, for example, is to measure how much does your language change from month to month, right? So basically, what is the similarity of this month's language to the language I was using in the previous month? And what turns out there is that basically in the first, let's say 30% of users' lifetime, your language changes a lot, but then it gets kind of stable and doesn't change from a month to month so much. So what this means is that basically the second hypothesis is true, right? That basically what happens to people is that they get stuck in the past, right? They basically, their language stops changing, the language of the community changes, the gap increases, and this is when the person kind of then departs the community. What's also interesting, if you now go and look at the person's absolute lifespan in the community, it seems like that all the people that depart communities, they depart the most. So basically, we can think of this as an elastic life cycle. So in a sense that everyone goes through this period of adolescence where they basically change their language towards the community, and then this kind of second part when their language rigidifies and the distance to the community increases. And this happens both for people that kind of live very short, right? These are my top short-lived users, people that kind of live for the medium amount, or people that live in the community, stay in the community for very long, right? So what you can do now is basically seeing just the initial interaction of a person very early on. We should be able to tell how long is the person going to stay in the community. So here we did just a very kind of simple prediction task. Imagine I see a person's first 10 posts either about beer or either about the breast cancer, and I want to predict when they will drop out from the community, right? Will they stay and become this kind of long-term contributor, or are they going to drop out? And what's interesting is that we can do these predictions really well. We basically get 40% relative improvement over the activity-based predictor. What I mean by that is one way how to say whether you will be a long-term contributor is to say how much are you participate at all, right? So above that, this kind of language practices and how much does a person adopt to community's language really matter. So that's kind of the first thing, is to identify people who will become long-term contributors and kind of to understand how language practices evolve evolve over time. So now instead of just trying to predict how long people will stay, maybe there is a way for us to kind of steer and influence human behavior in these online communities. And one way how to do this is basically that we realized that humans work really hard to earn badges. And what do badges mean, right? So if you think, for example, the offline world is full of these examples. Probably the best example is army. Right, in army, people get these badges. They are basically willing to risk lives for these badges, and they put the badges on the chests. Science is all about badges, right? Here's kind of the most wanted science badge. It's a Nobel Prize, right? All our grant proposals, science publications, and so on, you can think of them also as some kind of badges. And also online world, like for example, education sites, encyclopedias, question answering sites, social networks like Foursquare, they all have this notion of badges that people can earn. Right? So the question really is, what are these badges doing to human behavior, and can we kind of model that and maybe come up with the optimal set of badges that have behavioral outcomes that we want to achieve, right? So why are badges nice is that because they play multiple roles. In a sense, they allow us to recognize a very wide range in types of activities of, let's say, of people, right? And the other one is that they both serve as credentials and create incentives, right? Somebody who has lots of badges, they earn trust and status in the community. But both badges provide people incentives to kind of go and try to get them. So the way we are thinking about this is basically we have this kind of utility-based mathematical model of how people behave, and the basic intuition is very simple. Imagine you have two choices in life. You can kind of go eat hamburgers, or you can go exercise, right? And then imagine the way I can now think of badges is just this kind of lines in this abstract space that once you cross the line, I give you a badge, right? So, and the idea is that users or people gain value by obtaining these badges. However, right, every one of us is kind of lazy, right? So, and the way we can kind of capture this laziness is by this vector that says, I like, eating 4 hamburgers and then I go exercise once, right? So that's kind of my preferred behavior that I like to do. And what basically the badge will do is, it will require me to shift my behavior, right? To kind of change the direction in which I'm moving, but shifting this behavior hurts, right? So now you have this kind of two competing forces in the model. In a sense, I want to earn badges, I want to cross that line. On the other hand, I don't want to change my behavior too much. I don't want to kind of change the direction in which I move, because that hurts. And what's interesting is that this very simple reasoning and this very simple model is already enough to explain what is going on in these online communities. And I'll show you some examples later, right? So the way basically we can think of badges are as this kind of magnets that basically attract you towards themselves. And then depending on kind of how you are moving through this space of possible actions in your life, you will basically get attracted by different badges, and basically you will take a different trajectory. And this is what I try to show with this kind of arrows, which you can think of them as some kind of vector diagram of how users navigate through. And now I can basically think of this as, where should I place these magnets so that the user trajectories through this space are, in some sense, the way I want them to be, so that basically I incentivize the behaviors I'd like to achieve. Right? And one place where we actually studied these badges and where we found exactly these things happening is the question answering website for programmers called Stack Overflow. So kind of if you ever written a program and you typed some kind of computer sciencey question into Google, you probably got an answer from Stack Overflow as your top hit. And this is a very active community. And for example, in this community, they would like to identify what are really good questions and what are really good answers. So for example, there is a badge called electorate badge that you get if you vote on exactly 600 questions, right? So basically you want to upvote or downvote 600 questions, and once you've done that, you will receive this badge. And what is interesting here, you see the time 0 is when a person receives a badge, and you can see how the number of question votes per day increases just above to the point when a person receives the badge, and then kind of goes down and drops at this back to this kind of baseline level. What you also see is, for example, that the yellow answer votes, actually that activity decreases a bit at the expense of the question voting. So these are kind of some examples of the behavior that is very nicely predicted by our model. And given that we have a model, we can now ask the second question, right? We can say, okay, but where should I place badges in order to achieve desired behavior or behavioral effects, right? And given that you have a model, you can basically come up with an algorithm and optimize this. And what comes out is very, very interesting things. For example, it turns out that if you make badges too easy to achieve, they won't result in change of the behavior. If you make them too hard to achieve, nobody will go after them. So there is this sweet spot in the middle and so on and so forth. And actually, we are now using this methodology and deploying it to online education, where we are trying to kind of provide badges to make students study harder, drop out less, and we are getting some encouraging results. So that's another thing that I wanted to say. And in this case, what I think is a very nice connection is basically, how do we create the right incentives, right? And right now in healthcare, there is a number of new incentive models that are being proposed, right? In terms of paying physicians based on the decreased risk or improvement in patient healthcare, right? Obama's initiative, and so on, right? And basically, an observation is that a great deal of healthcare costs could be addressed by basically preventive healthcare, in a sense that, can we make people live healthier lives? And as in the previous talk, we saw how kind of Atul's body weight is kind of, getting better just because he's measuring himself. Right now, imagine what he would do if we would give him a badge every 2 weeks for eating healthy or something. So these are examples of things where these things can be applied. And the last thing I want to show is when I was talking about the web as a sensor, another place where web is really the sensor is media, right? So basically, all the stories, all the kind of what happens in the world echoes online. And in this space, what we've been doing is we've been working and collecting data since August 2008. Basically, this is now 5 years, where we basically have complete picture of US online media space. This basically means we get around 30 million documents per day. So overall, we have 6 billion documents, 20 terabytes of data, basically everything you find on Google News, plus around 4 million blogs, plus a good chunk of Twitter. And now the question is, right, given that I have now this kind of telescope into the world, what kind of interesting things can I compute over this, and what can I learn about how the world works? So in this case, what we are trying to do is basically do what we call meme tracking, where the idea is that you want to trace textual phrases as they spread through online media. And the interesting observation here is that basically these textual phrases tend to mutate. They almost like kind of the way the genes mutate, these phrases also mutate. And here I'm showing you this kind of mutation graph or mutation tree of a phrase about the discovery of the Higgs boson about a year ago, right? So the way we think about this is basically we think about this that we have phrases that are mutational variants of each other. And one of the problems here is how do we identify all the phrases that kind of mutated from the same mother phrase, right? And the way we do this is basically the same as you do in biological sequence analysis when you do basically string Getty distances and you try to align different sequences. We do the same thing here, where basically every phrase goes and kind of asks itself, who could be my potential parents? And now that you have this kind of potential parent graph, you can now try to identify clusters in it such that all the phrases at the end kind of evolve from the same mother phrase, right? And basically what is interesting is that we can do this on this large scale. So using a single server, we can do this in a few days over the whole 6 billion document database. What's interesting now is that we can go and observe information dynamics. So for example, this is a graph of where every color is a different phrase. X-axis is time, Y-axis is volume, and this is around the Boston bombings. And the two spikes, if you look at them, they exactly correspond to when the event happened, and the other one when they were kind of searching for the person who did it and all the drama around there. Another thing that's more related to healthcare is actually we are now trying to understand how kind of media and physician behavior, how do they relate to each other. So for example, with our collaborators Nigam Shah, who's here at Stanford, and Gregor Stiglitz, who's back in Maribor in Slovenia, we are trying to understand how, for example, FDA drug alerts affect physicians' web searching behavior, and how does the media, what role does the media play. So for example, here I'm showing you just one simple plot where the green line is the time when FDA issued this report when this antidepressant Celexa was discovered to lead to abnormal heart rhythms. And you see that basically kind of for 2 weeks nothing happened, right? So the blue line here represents the media reporting and the amount of media reporting on this story, and the red line here is actually data about healthcare professionals searching for this particular effect and this particular disease drug on uptodate.com website, which is kind of a search engine for health professionals. And you see that basically there is this 2-week gap, and trying to understand why is there this gap between kind of the report, media reporting, which there is that little bump where kind of media seemed to caught on the story, but kind of physicians reacted much later. So this I just wanted to show as an example of where basically we can use this kind of large-scale web data as a platform for large-scale analysis of online media for healthcare-related topics, and basically really understand what is the role of media in terms of our behavior and the way the medical or healthcare industry works. So with that, I'm done, and we can take questions later.